Well, it is a happy Saturday. It snuck up on us. It is nice and warm. Hope everyone is having a grand time. I almost went to Addison, but I had to get up super early to get my daughter on her orchestra trip. Didn't get home till 5:30 in the morning. Um, so I didn't go to Addison, but there's a big air show out there. Y'all should really go. All right. So what we have is secants and circles. This is part 2 of chapter 11-6. And we're going to, just like we did in chords, we're going to look at the basic definition. We're not going to get too in depth. So I just have 3 quick examples. Now we have, when secants are involved, we have an outside part and an inside part right here. And the general rule is outside times whole. So here's the outside part, 8. And here's the whole part, x plus 8, okay, times outside times whole. And the whole part is 16. So just remember that when you're doing the whole part, it's from this point all the way over. So we just set up our algebra equation. So we have 7 times 16 is equal to 8 times 8 plus x. All right. So we're just going to go ahead and knock this out into the equation. And that's 70 plus 42, so that is 112, right? 112 is equal to 64 plus x. Subtract 64 from that, so that's just nothing more than 36, 46, 48, right? So we got 48 on this side is equal to, that's an 8x right there. Did I do it? There. 48 is equal to 8x, and of course x is equal to a whopping big 6. To find our geometry answer, we just plug in it right in there. That'd be 14. All right. So we got 16 here, a little bit longer, a little bit shorter secant line, secant segment, which is 14. All right, so let's take a look at the next example. Boom. It's still going to be the same thing. Your book does something slightly different. They'll square this. They'll say, because you got a tangent. So, well, yeah, it's tangent right here. Tangent at point D. All right. But I taught y'all basically to use the same thing that you've been doing. Outside times whole is equal to outside times whole. Here's the outside part. Okay, so that's 6. Well, it just so happens to be the whole part is 6. So you just have 6 times 6, all right, is equal to outside 3 times the whole thing. And the whole thing is 3 plus x. 3 plus x. Distribute that 3 to the 3 plus x. So you got 36 is equal to 9 plus 3x. And, you know, we can do quadratics if that was an x right there, something like that. So you got to be prepared for that. You're going to subtract 9 on both sides, so that gives you 27. 27 is equal to 3x. And we picked nice, easy number because all we're doing is just rehearsing the definition. But as you've seen on your last 3 homeworks, it was pretty rare to get whole numbers. It was almost all decimals or weird stuff. So x is equal to 9. All right. Geometry answer, this length is 12. That length is 6. We're all happy. Moving on to the last example. All right, and this is just more practice. Outside times whole is equal to outside times whole. I probably should have put a quadratic on here just for the fun of it. Alrighty, so here we have 2 times x plus 5. Do you see where the x plus 5 comes from? If not, pause and investigate. Is equal to 3 times 8. All right, so 2x plus 10 is equal to 24. 2x is going to equal to 14, and of course x is equal to 7. Why did I put an x over there? My brain doesn't work on Saturdays. All right. So, and then the algebra answer, this will be a length of 10 right here, and this whole thing is 12. Alrighty, I'm going to go ahead and knock this one out and get circles going here quickly. I mean, equation and circle. See ya.